In this lesson, we shall focus on differential calculus. Okay, this kind of calculus we are doing at school has a specific name, and we call it differential. We call it differential calculus. What does differential calculus mean? Well, it is the calculus of derivatives and differentials. So now there's something we do that is called integral calculus. Now, integral calculus is a form of calculus that performs something we call integration. So if, for example, you have the integral of dx, you can find this one. You can find the integral of x to the power n, x to the power n with respect to x. Okay, so this here, you can be able to find x to the power n with respect to x is 1 over n plus 1, x to the power n plus 1 plus c, okay? Provided n is not equal to -1. This is called the process of finding, of evaluating. This is called integration. And if you don't want to call it, it is the reverse process of differentiation. Some people call it anti-differentiation. Okay, so the anti-differentiation part of it is motivated by the fact that it is the opposite process of differentiation. But in school, okay, if you're doing technical math, we also cover anti-differentiation, but yeah, at this point, because this is just pure mathematics, we shall be focusing on what we call differential calculus. Okay, so it's all good and well, and the ball is in your court, and you can begin tossing, you can begin playing, you can begin celebrating, and you can begin having great fun. Okay, let's get started, because this is one exciting moment for us to learn more. Okay, we're starting from the basics of calculus, and we're building from the bottom up. Determine, this is always the first question, f primed of x from first principles if f of x equals -2x squared minus 1. This one here is a concept that we need to learn. First principles. What is the formula? It's given in the matric examination. So f primed becomes the limit as h tends to 0 of f of x plus h minus f of x. All this is divided by what? All this is divided by h. Right, so pay particular attention to this, because this is awesome stuff. But yeah, very exciting stuff. That is the formula. So we proceed to therefore say f prime of x becomes the limit as h approaches 0 of f at x plus h. Now, if f of x is given to be -2x squared minus 1, f at x plus h is -2, open bracket, x plus h squared minus 1 minus, open bracket, f of x is exactly the same as minus twice x squared minus 1, okay, like so. And this is divided by, okay, it is divided by h. Now, pay particular attention to this, because this is very, very important. It's very important, but extremely important for us to take note of, because we are learning here. We are the learning generation, but our aim is to produce distinctions in mathematics, but 100% in mathematics. So we have -2 open bracket. What is x plus h squared? So we have x squared. 2 times x times h is actually 2xh. Then we have h squared minus 1.
Sir,
Yes, please. Welcome. Right. Welcome. So we therefore have plus 2x squared plus 1 all divided by h. Okay, that is what we have. So then we have f primed of x, which is the limit. As h tends to 0. Okay, and by distribution here, we're going to have minus 2x squared minus 4x h, because minus 2 times h squared is actually minus 2h squared minus 1 plus 2x squared plus 1. All these is divided by h equals the limit. The limit as h approaches 0. Okay, let us deal with some of the cancellations of terms, like minus 2x squared and x squared cancel out, minus 1 and 1 cancel out, and we have minus 4x h minus 2h squared, all divided by h. This equals the limit as h approaches 0. Now, h here is a common factor, giving us minus 4x minus 2h. Okay, and this is divided by h, like so. Okay, further simplification allows us to cancel h and h, and this yields the limit as h tends to 0 of minus 4x minus 2h. Right, so this is f primed of x. Now, as h tends to 0, what we're able to see here is that f primed is minus 4x minus 2 times 0. Right, so this is minus 2 times 0. Okay, well, you put this in parentheses, minus 2 times 0. And this is minus 4x. Okay, now this here becomes the answer to this question. Any question, Nambusa? If you have a question, let us know. If you have a suggestion, you have an observation, let us know. You're observing an error somewhere, you're welcome to talk to us about it and make a clear indication of where you are seeing the error so that we can begin to address that. The next thing is we're moving on to the next question in a step-by-step fashion as follows. Right, we actually, in the next question, need to determine f primed of x if it is given that f of x is minus 2x cubed plus 3x squared. Here we use the power rule. Right, the power rule. And what does the power rule say? Well, the power rule is clear that f of x equals x to the power n implies that f primed of x is nx to the power n minus 1. This is the power rule of differentiation. F of x equals x to the power n implies that the derivative is nx to the power n minus 1. Okay, we are here and we want to determine f primed of x if it is given that f of x is this. So we proceed in a step-by-step fashion as follows. F of x minus 2x cubed plus 3x squared. We find the derivative of this f primed by using the power rule. Here is the power rule. So it is f primed of x that we have. Okay, minus 2 times. Okay, yeah, so this one is minus 2 times 3. X to the power 3 minus 1. 3 times 2. X to the power 2 minus 1. Okay, so this is the derivative. So what are we doing here? What we do is we bring down the powers and we subtract 1 from the powers themselves. Bring down 3 and subtract 1 from 3. Bring down 2, we've done that, and we subtract 1 from 2. And this is called the power rule because we're dealing with the powers of x. We proceed as follows. F primed of x equals, what is minus 2 times 3? It's actually minus 6x to the power 2 because 3 minus 1 is 2, plus 3 times 2 is 6x to the power 2 minus 1, giving us a 1. Okay, now let's continue in a step-by-step fashion and get the result. So what is the next thing that is left of us to do? Okay, it is very clear that at this point, we have solved this problem and we have got the final answer. And this is the final answer. And we are done with this question. And we have determined the derivative of the function f at x. If ever you have a question, please let us know. If you ever have a question, talk to us about it. Okay, here we have found f prime of x using the power rule of differentiation. What does the power rule say? It says that if we have x to the power n, the derivative, which is f prime of x, or the slope at any point, instantaneous slope, is n x to the power n minus 1. So you drop the n and subtract 1 from the n. Okay, this is good news for us. Let's continue. Next question. Right, in the next question, we analyze 7.2.2 because we've already looked at 7.2.1. Meaning y is 2x plus 1 over the square root of 4x. This is actually y equals 2x plus 1 over the square root of 4 like this. Okay, so y is twice x plus the square root of 4, because now the square root of 4x, you can break it down to the square root of 4 square root of x. The square root of 4 is 1/2. The square root of x is x to the power 1/2, like so. At what point we're able to observe that, or at this point we're able to observe that here we have 1/2 x to the minus 1/2, meaning y is twice x plus 1/2 x to the minus 1/2. Pay attention to this. Now, dy dx equals, what is the derivative of 2x? Okay, there's no power on the x, so make it 1. And we drop the 1. Subtracting 1 from 1 minus that. Okay. Okay, take it easy. Okay, so yeah, we bring down by the power rule, because the power rule says, we'll remind each other about the power rule. If you have a power like that, then you get dy dx, and this dy dx is nx to the power n minus 1. Meaning here you bring down the power. So here you bring down the power minus 1/2, and from that you subtract 1 from the power. Okay, subtract 1 from the power. Meaning you have dy dx. Okay, so yeah, we brought down the 1 and it multiplies the 2 and subtract 1 from 1, and then we have 1/2, and then brought down minus 1/2 the power, and then we subtract 1 from the power minus 1/2. 2 by 1 is a 2, right? And we have x to the power 1 minus 1 is 0. Okay, so yeah, positive times negative is negative. 1 by 1 it's a 1. 4 x to the power minus 3/2. Meaning that we have dy dx. What is x to the power 0? X to the power 0, it's a 1 times 2, giving us a 2. And then you have x to the power 3/2. Okay, and this is the answer. Because x to the power 0 is 1, but now this is very important. It is 1 provided x is non-zero. Okay, so this is very important, because at grade 10, you were taught that 0 to the power 0 is undefined. 0 to the power 0 is undefined. You're taught at grade 10. But there are things that you know. For example, you already know that 2 to the power 0 is a 1, 3 to the power 0 is a 1, 5 to the power 0 it's a 1. But the moment you raise 0 to the power 0, it is not 1. It is not. Okay. Right. So there are schools of thought on these things. Very, very important there. But yeah, take note of this. And we have found dy dx. Okay. The way we read this one here at university, because these things are done at university, but in detail, at university, you say dy dx. So you read this one. How do you read it? You read it by saying dy dx. Dy dx. So when you say dy dx, that's what you mean. But you see, it is dy dx that it has to be read as, and it is not dy over dx. It's not division, please. It's not division. It is reverse division, but this is called an operator. So the operator here is the operator d dx. It's not division. This is not algebra. This is advanced mathematics. So you need to make sure. Okay, yeah, those students who are going to do technical math, technical math has also aspects of what you call integral calculus, which is also called anti-differentiation. Anti-differentiation, so we can actually be in a position to get the slopes of things, and we can go in the opposite as well. Okay, we're good. Next question. Right, let's look at the next one. The next one is a very nice question and saying the graph of the function, the graph y equals f prime of x has the minimum turning point at 1 and minus 3. Determine the values of x for which f is concave down. The minute the examiner says the graph y equals f prime of x, so there's a graph which has the minimum turning point. So it means that we're dealing with a parabola. Okay, we do parabola graphs in grade 11. And now the graph y equals f prime of x has a minimum turning point at 1 and minus 3. Like this. This graph has a minimum turning point at this point. So it has a turning point, but it's minimum. Okay, so here, there's the minimum turning point. There's the minimum turning point. Now, the examiner goes on to say, in particular, it is at this point. What does it mean that this is a minimum turning point? Well, we're going to analyze that. What it means that we can find dy dx, or let's write it like this. Okay, yar. Okay, yard. Doesn't matter. Okay, let's write it like that. So let's start by saying y is f primed of x. Dy dx f double primed of x. So you can find the derivative of this, because if now you're given a function, then you can find dy dx of the function, and the function is f primed of x, so the derivative becomes f double primed of x. F double primed of x. So that dy dx evaluated at x equals 1 equals f double primed at 1. So we're saying dy dx is evaluated at x equals 1. So now if the examiner is saying that, so the graph of this has a minimum turning point at this point, it means that the derivative of these equals 0, indeed, at the point x equals 1. What is the meaning of all these things here? We need to determine the values of x for which f is concave down. What does concave down mean? We analyze that in green. Now, concave down would mean that the second derivative of the function at x is negative. That's what concave down means. So concave down means that, sir, this means concave. This means concave down. Okay, what does concave down mean? Concave down means that the second derivative is actually a negative. The second derivative is a negative, then we have concave down. And concave down in terms of shapes means you have this kind of shape here and your, okay. Now I want us to look at these, but look at these very, very carefully. So if we are then saying the second derivative itself is negative, what then does it mean? Well, remember that if you have this function here and it has its line of symmetry here in the middle through the vertex of the parabola, and so now we are interested in the second derivative. The second derivative negative defines the slope. So this guy here defines the slope over f double prime of x. Okay, so it defines the slope over f prime, double prime of x. Defines the slope over this function. Or you can say it defines the slope. Sorry, it states the slope. Okay, so this one here is the slope at any point, on y equals f prime of x. The slope at any point on that one. The slope at any point on that one. Okay. And this now is the slope over this function. The slope at any point on this function. Okay, now if the second derivative is negative, it means the slope is negative, and now the slope here is going to be negative in terms of f double primed of x, and then f double primed of x here is going to be, so here it's negative, but here it's going to be positive because, so you put some pluses here. So in other words, when we are moving up to this side here, the slope is positive. Tricky question for the 2 marks. Okay, need to analyze just your second derivatives here, and we are in business. Okay. And therefore, if we want to say it's concave down, the values of x for which f is concave down, so for which the second derivative is negative. Concave down means the second derivative of x is negative, and the second derivative occurs indeed, and it is negative when x is actually less than 1. And that is the answer. When x is less than 1. And this is the answer to the question. Please make sure you understand this. When x is less than 1. You don't understand, you ask, because we are producing mathematicians here, but we're not producing ordinary mathematicians, but we are producing mathematicians with distinction. Very important. With distinction. Take note of this and ask any question. Ask any question. Ask any question, my friend. You okay? Okay, we proceed. Okay, this is recorded, so you'll have a chance to, okay, you'll have a chance to watch and enjoy. Question 8 is long. It's about a graph whose dividing equation is f of x equals x cubed plus 4x squared minus 7x minus 10. Write down the y-intercept of f. Let's find the y-intercepts. Okay, at grade 10, grade 9, we know how to find the y-intercept of a function. So we're looking at 8.1, and we want to find the y-intercept. So in 8.1 now, we write that we want to find the y-intercept. To find the y-intercept, you let x be equal to 0. So that f of x equals x cubed plus 4x squared minus 7x minus 10. So you have f of 0, which is 0 cubed plus 4, 0 squared minus 7 times 0 minus 10. And then f of 0, it is minus 10. And this is our intercept, minus 10. And, well, you can, as a consequence, be able to write that when x is 0, y is minus 10, and this becomes the y-intercept. It can be written as a point with a set of coordinates, both the abscissor and the ordinate written. Both the abscissor and the ordinate written. Now, I want to speak about these. So, now, as you look at these very carefully, the notion of the abscissor and ordinates. Right, so these notions become very, very important for us, and I want to make mention of these here. And we mention the following. So, right. So the notion of the abscissor, it being the x value, so you give it a point. This one here is called the abscissor. Right, it is called the abscissor. And this guy is called the ordinate. In other words, okay, this is called the abscissor, but if it's only one, but now there can be many, like, yeah, yeah, so this guy here is called abscissae, okay? Abscissae is the plural form of that. Right, abscissae is the plural form of that, and you need to take note of this. So yeah, but we found the y-intercept, and the y-intercept is this. This y-intercept is a set of coordinates called an ordered pair that has both the abscissor and the ordinate listed in order, and hence is called, this is called an ordered. It's called an ordered pair. It's called an ordered pair. Next question. In 8.2, we analyze with great caution the next question. Show that 2 is a root of the equation f of x equals 0. Now, you want to show that it's a root of the equation. To be a root of the equation, it means it must satisfy this equation. What is the equation? The equation is that f of x equals 0. And if you put 2, therefore, you must get that x equals 0. In other words, we understand, therefore, that we need to let x be 2. Let x be 2, which means that if you have f of x equals x cubed plus 4x squared minus 7x minus 10, so that f of 2 equals 2 cubed plus 4 times 2 squared minus 7 times 2 minus 10. I want to show that this is a root. 2 to the power 3. This one is 8. 2 squared, it's a 4 by 4, 16. 2 by 4, 7 by 2 is a 14 minus 10. This is exactly 8 plus 16 is 24. And minus 14 minus 10 is also 24. And 24 minus 24 is 0. And by dint of this, we are able to make the conclusion, therefore, x equals 2. X equals 2 is a root. Right, it's a root of the equation. Now, this equation has multiple roots, but x equals 2 is the root of the equation f of x equals 0. F of x equals 0. Like so. Take note of this as we move forward, because, yeah, there are a lot of things that we will make mention of as we move along. All right. We are we are here to move to move along. Let us look at the next question. Yeah. Right. So we continue. Right, in continuing, we take note of several things that are very important, and we look at the next question. But we look at the question 8.3. Let's look at that one. 8.3 is purely a grade 11 concept, and in grade 11 and grade 10, we're asked to factorize, and most of the times we need to factorize polynomials. And cubic polynomials are at grade 10 with no exception. Let us pay particular attention to the factorization techniques we need to apply. But the examiner said hence. Why does the examiner have to say hence sometimes in a math exam? They say hence is a past exam questions because the examiner knows that this question must be done using the result from above, but also you can say hence or otherwise. Right? The examiner did not say otherwise, so the examiner, with the greatest level of anticipation, anticipates you to make use of the previous answer to factorize f of x completely. Let's focus on these with particular attention. Okay, given the cubic function, f of x, okay, equals x cubed plus 4x squared minus 7x minus 10, like so. What do we do here? We want to factorize f of x completely. Now, with the examiner at hand, so then we must use the fact that x2 is the root. So at grade 10 and grade 11, we learn something we call the long. We call it the long division. Long division method. If we don't want to call the long division method, we call it the long division algorithm. X minus 2. X cubed plus 4x squared minus 7x minus 10. Okay. So you have x cubed divided by x. What is x cubed divided by x? Okay. X cubed divided by x is exactly x squared. Okay, we have lots of optimization questions and a lot of applications of calculus, but yeah, x cubed divided by x gives us exactly x squared, and x by x squared gives us x cubed, minus 2 by x squared is minus 2x squared. We put a minus. Okay, yeah. So we introduce a minus outside the parenthesis, like so. Okay, so x squared, x cubed minus x cubed is a 0. Here we have negative times negative giving us a plus 2x squared. So 4x squared plus 2x squared is 6x squared. We have 6x squared divided by x, and then we have 6x. And x by 6x is exactly 6x squared. Minus 2 by 6 is minus 12x. Okay, so now we have 6x squared minus 6x squared is 0, and then you have here, okay, here you can drop minus 10. Here you can drop minus 10. So that we have 6x squared minus 6x squared, which gives us a 0. Okay, here you have the negative, which is 12x. 12x minus 7 is 5x. Okay. Now, here, what is 5x divided by x, which is 5? Okay, x by 5 is 5x. Minus 2 by 5 is a minus 10. Okay, minus 5x, 5x minus 5x is 0. And this one is minus 10 plus 10 is 0, giving us a big 0. There's something we learned at grade 3 and primary and grade 1 mathematics, and it comes back right now. At grade 1, we were taught division, and the teacher said The teacher said if you divide 7 by 5, 7 goes how many times into 5 goes how many times into 7? It goes once, and the remainder is 2 out of 5. And the teachers taught that, said that if you divide this kind of division, this one is called the quotient, and the 2 is the remainder, because when you divide 7 by 5, 5 goes one time only into 7, leaving a remainder of 2 out of 5. Okay, this is good news, and yeah, we're in business, and I want us to pick more momentum because we want to be A students. Okay, yeah. This coming week, I want people to attend every day because most of you guys are not even going to school these days, and you're not writing every day, So most of you guys can be able to really attend March this coming week. And I think that is very important. We realize that. Okay. So that this means this kind of division. This at the bottom thing here is called the remainder. This is called the remainder. In other words, if you divide x cubed plus 4x squared minus 7x minus 10. Okay, yar. Okay, look at this. Divide these by x minus 2, my friends. And if you divide these, the quotient sits at the top. What is it? It's x squared plus 6x plus 5. Remainder 0 out of x minus 2. Okay, what is 0 divided by x minus 2? It's a big note. So, which is x squared plus 6x plus 5. So you cross multiply. So yeah, minus 10. Cross multiply, this x minus 2 is going to sit next to, okay. So you have the x plus 5, then you multiply by x minus 2. Okay, yeah, let me write this nicely. I feel that a nicer presentation would be that if you cross multiply, this is going to come and sit here. The x minus 2 is going to come and sit here. By so doing, you have x minus 2, x squared plus 6x plus 5. Okay. You need to factorize this completely when we're using long division, but yeah, I know that you can do well with long division, or what you call the division algorithm, the long division algorithm, just the division algorithm. So what are the factors of x squared plus 6x plus 5? And the factors are clearly x plus 1 and x plus 5, like so. This here, okay, remember they said factorize f of x completely, and this is the factorization of that. F of x has been factorized completely in its completeness, in its entirety. So yeah, take note of that. And obviously, I mean, one is welcome to right. So the final answer, therefore, must be written as follows. So I'm going to write the final answer in green color, and I'm going to say that if, okay, F is, okay, we've already factorized and have written that, so it is x minus 2 within, in parentheses, x plus 1, like that, and x plus 5. Okay, yeah, we've factorized. We have factorized. Okay, because we're to factorize f of x, but completely, and we've done that. Right, so if you have a question, please let us know. And tell us what your question is so that we can address your question. Because we want to produce distinctions.
Entirety.
We want to produce distinctions. Next point. The next question. Okay, if it is further given that the coordinates of the turning points are approximately this one and that one, Right, draw a sketch graph of f and label all intercepts with the axis. Okay, right, there are a couple of things that we already know and we're good. But yeah, the x-intercepts, we know that f of x is x minus 2 in parentheses, x plus 1, x plus 5. My friends, this is 0. If this is 0, 2 minus 1 minus 5. So, okay, these three guys here are called the x-intercepts. We call these three guys the x-intercepts, and if they okay only when y is 0. Okay, good. Yeah, we're in business now. I'm gonna draw the coordinate axis and have y together with x. Right, when x is minus 1, minus 5, 2. And then there is our y-intercept is minus 10. And then we can just put our turning points. Okay, here, this one is our x-intercept, so we don't miss them. They are 2 minus 1 minus 5. And also this one here is our y-intercept. Okay, so we can't miss that. Next, we position our intercepts with the coordinate axis at this point. These are namely 0, 7 and minus 12, 6. 0, 7 minus 12, 6. So, okay, minus 12, 6. Okay, and also there's another one, minus 3, 4 and 12, 8. Yeah, minus 3, 4 is somewhere here. And 20, 0, 8. This point is a vertex. Minus 3, 4, decimal comma, 20, 8. So we're good. So that then in the end, what we have in here is as follows. Let's draw the graph. So it's going to have a turning point here. And then it's going to cut here. So you have this and that. So which means f of x minus 2, x plus 1, x plus 5. Okay. Okay, so you have to draw the rough graph. So that is the rough graph. That is the rough graph. Okay. That is the rough graph. We continue. Um, okay. This is the rough graph. And the intercepts have been shown, and everything has been shown there. Your salient points, your intercepts with the axis, both the x and y, your vertices, and your y-intercept as well. Okay, we're good. We're good. Use your graph to determine the values of x for which this is the case, yeah? Let's do that quickly. If you have the for that these are your coordinate axes, and we have already seen that the graph is like this. We have already seen that this is a minus 5, this is a minus 1. Okay, you must forgive me if I lose you, because, yeah, I should not lose you, but instead, yeah, it might be the network, whatever the reason. Always reconnect because, yeah, this one I'm going to post this video, please. So you need to make sure, obviously, I mean, I'm going to make this video really available. So it's being recorded in, it's lots of exam questions that are here. These are past exam questions on calculus as they are asked. So get ready for more action. But for more thrilling action, we are looking at parts where the second, rather f prime of x itself is negative. Where is it negative? Where is the slope, the gradient of this function negative? Now, the gradient is positive here. Okay. The gradient is a negative here. The gradient is positive here. Okay. So use your graph to determine the values of x for which the gradient is negative. Where is the gradient negative? Where is the gradient negative? The gradient is surely negative between what values of x, okay? So the gradient is clearly negative whenever x is an element of the open interval from -3 decimal comma 4 semicolon 0,7 decimal comma. Now, this here can be written like in many ways. Okay, you can say also x is, yeah, like that. Okay, let me write a different result. Just a different notation, but yeah, same result. Okay, it's the same answer, but yeah, written in different ways. So you can then say -3 decimal comma 4 is less than x less than 0,7. I keep losing. I don't know why. It's technology. Forgive me if I lose you, because I should not lose anybody. I should not lose anybody. The gradient, the slope is negative, because the function is going down slope between -3 decimal comma 4 and 0 decimal comma 7. Okay, just note those things there. We'll look at the next one. We look at the next one. Um, we'll look at the next one. Okay. -5. Okay. Okay, pay attention. -3, 4, t, 8. Okay. -12,6. Okay, focus on this and make sure you understand that. Use a graph to determine the values of x for which the gradient of a tangent to f will be a minimum. Right, so to look at that particular question, and we're looking at 8.5.2, the gradient of a tangent to f will be a minimum. So let us look at these very carefully. So the original function is f of x equals x cubed plus 4x squared minus 7x minus 10. Let's find the first derivative. Bring down 3 using the power rule. Power rule says bring down 3, subtract 1 from 3. 4 times 2, x to the power of 2 minus 1, bring down 2, subtract 1 from 2. Okay, on the power of x here is 1, so bring down 1, then subtract 1, like this. Okay, the derivative of a constant, a number with no x, the derivative is a big naught. There's a minus there, but the derivative of a constant is 0. So we say that, okay, let me use the as well for just the completeness of this. So we proceed to then say the derivative of yeah, I want to say the derivative of a constant is 0. Y equals a constant. Y equals C a constant has certain mathematical implications. So Y equals C a constant. Hey, I keep losing my other student here. Please, if I lose you, just join. But yeah, I'm making every effort. This one is recorded. So y equals c, and c a constant, but an algebraic constant, implies that dy dx equals naught. Yeah. Yeah, just think of this. Just think of this, and make sure you understand that. The derivative of a constant is zero, meaning the derivative of a number is zero. Okay, y equals 3 dy dx 0. Okay, if y is a number, then the derivative is 0 of a number. Okay, this notation is dy dx, and this notation dy dx. What is dy dx? It is the derivative. Derivative or the slope. We don't call it the slope, we call it the gradient. Okay, so with f primed. So this is 3x to the power 3 minus 1, which is 2, plus 8x minus 7x to the power 0, because 1 minus 1 is 0, meaning f prime of x equals 3x squared plus 8x minus 7. And that is the answer. And that becomes, okay, but yeah, let's see. Use the graph to determine the values of x. Yeah, we need to find the values of x. Need to find the values of x for which the gradient of a tangent. Okay, this one is the slope of a tangent, but we need to find the gradient of a tangent. So to find the gradient, this here represents a tangent. So the gradient of a tangent would be the second derivative, which is 6x plus 8. This is the gradient of a tangent, and this gradient of a tangent itself will be a minimum. So if this gradient is to be a minimum, so it means that its derivative must be 0. The derivative must be 0. Okay, if the derivative is 0 for minimum, so equals 0 always when they say you need to find the minimum or maximum, so for minimum. Okay, so which means therefore that we have 6 x plus 8 equals 0, and that means x equals, you transpose the 8, it becomes negative, and divide by 6, and this means that you have minus 4/3, and minus 4/3 is the culprit, Okay, so that x here is actually equal to minus 4/3. Now pay particular attention to these things here. X equals minus 4/3. X equals minus 4/3, and this is the answer. And this answer can be written in a billion ways, and one can say it's minus 1 comma decimal comma 3 3. Okay, recurring 3 3 recurring, yeah, but you can truncate it, round off. You can round off. All right. Okay. 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 So we're looking at 8.5.3. We're looking at 8.5.3. Let's look at 8.5.3. So at 8.5.3, we continue to, yeah. Okay, yeah. This is going to determine the values of x for which f prime of x is. Okay, f prime of x times f double prime of x is less than or equal to 0. Pay particular attention. I want us to uh bring more analysis to these. So yeah, just give these your attention, because yeah, we're building mathematicians here and scientists and future scientists, and okay. Okay. Okay, now this is what we have. This is what we have. Now look at these now. So, okay, first things first, we drew a rough sketch of the graph itself. Let us remind each other. Okay, I'm just going to draw it here. Right, so this rough graph itself is of this shape, and its geometrical formation. It goes up, then comes down and does all this. You have -5, -1, -10, and you have here 2. Right, so which is 0,7 -12,6. Yeah. Okay, which is -3,4, 20,8. I know. Okay. Yeah. Okay. Now we're here. So we're dealing with this is the graph of the function f, but the derivative of it is the slope of it. So the slope here is, because it's steeper, it's positive. Here is going down slope, it's negative slope. Yeah, okay, these are slopes, gradients, the derivatives. The positive slopes here because it's going up slope. Use your graph to determine the values of x for which f prime of x times f double prime of x is less or equal to 0. Now, this is what we have now. This is what we have now here. But there are two functions we are dealing with here, but also we're dealing with the other function. And the other function itself is the second derivative of the function f of x. Let's analyze that. If the original function is f of x equals, we remember it, and we just put it down on paper, right? So we have that it is x cubed plus 4x squared minus 7x minus 10. The first derivative, 3x squared plus 8x minus 7. Okay, this becomes the first derivative. What is the second? So this one is going to be 6x plus 8. Okay. Now, yeah, we can sketch this graph here. Okay, but we've already got... We've already got this x value, so it is occurring at -1 decimal comma 3 recurring. So, all right, if that is true, okay, so if that is true, okay, yeah, okay, pay attention. Right, yeah, we've already got that x is -4/3. Where is it -4/3? Okay, it is -4/3 here. So yeah, it's -4/3. Okay, so x is -4/3. Okay, which is -1 decimal comma 3. -1 comma 3. So it's sitting here. This x value. But if we want to draw the graph of these here so that we can compare the two, yeah, we can look at the y-intercept when x is 0 and y becomes 8. Let's draw the graph connecting the 2 points like this. Connecting the 2 points like that. Okay, now if you connect the 2 points, then let's analyze what's happening here. So there are a couple of things that are primary but very key, and what are they? This is the graph of the second derivative function, and This second derivative function, therefore, here is negative, and the second derivative is positive. Okay, yeah, this is the second derivative function, and it is positive y all the way up. Now, let us look at what's happening here. So when you're multiplying two functions and you're getting a negative, it means that one of them is negative and the other one is positive. So the result is negative and is less or equal to 0. Positive, negative, negative is less or equal to 0. Um, okay, I kept losing Nombuso. I'm so sorry. Apologies. Okay, now whenever you have that, if the product of these two functions is less or equal to 0, now you have that obviously product of these two is less or equal to 0. Yeah, one is negative. Let's look at the case where this f dot prime is negative. So this slope is negative. So if this slope is negative, it occurs at a time when is it negative? It is negative from here up to here. It is negative, but we can see clearly here at this point, you have interesting things. You have very, very interesting things. But now, yeah, we need to be actually extra vigilant and extra careful. We don't need to like make ambiguities here. We need to ensure that everything is okay. So at the point that this line we're drawn here cuts the x-axis, we know that x is minus 4/3 minus 1 comma 33. Yeah, 1.33 minus. So at this point, that is when this is positive, and so this second derivative is positive and this is negative. So and that is between minus 4.3 4/3 to 0.7. So which means that x lies between minus 4/3 0.7, which means it is 1.3 cabling less than x less than 0.7. So we continue to check here. We continue to check here. So this one here is less than x less than 0.7. Yeah, so with this is negative slope and the function itself is positive. So, but also we're not only looking at negative positive, but you're also looking at positive negative. So, which means that you have a positive. This one is positive here and this one is negative. And it happens up to this point. So, which means that, or you also have that from minus. So whenever x is less or equal to minus 3 decimal comma 4, you're able to see that this one here has positive slope, and this one here is going to have negative, negative, negative. Just graphing the second derivative function here, it is negative. So yeah, we have that. So there are two answers to this particular question, and they are as follows. It is x less or equal to minus 3 comma 4, or we have that. Okay, we have this one as well. Is our answer or that one? So we also have minus 1.33 less than x less than 0.7. Okay, so yeah, just look at that one is 33 here. It is exactly 33 here. It is exactly 33 there. So we continue to solve. We continue to solve more problems on this kind of calculus. This kind of calculus is called differential calculus because it is focusing on differentials and derivatives. And yeah, okay. Yeah, please forgive me if I lose you. I should not lose you. I should not lose you. Right, I feel so sad if I lose you. So yeah, but now I'm gonna send this recording just to make sure that everybody is okay. I'm gonna send this recording to make sure that Everyone is all right. So your we continue. We continue with the next question. Right. So at this point, we're saying a wire. A wire 12 meters long is cut into two pieces. One part is bent to form an equilateral triangle and the other a square. A side of the triangle has length 2x meters. Write down the length of a side of the square in terms of x. And we look at that for just a beautiful 2 marks. Let's get started. So here's a wire, and this wire is cut into two pieces. One piece is bent to form a triangle, and the other one is, okay, but not just a triangle, but an equilateral triangle. And an equilateral triangle is the kind of triangle that has specific properties that all the sides or all adjacent sides are equal in length. And now we have a geometrical square with all adjacent sides equal in length as well. But as a side of the triangle has a length 2x. In other words, we're going to put 2x, 2x, 2x here like so. Write down the length of the side of the triangle of the square in terms of x. Right side of the square in terms of x. We do the following. We do the following. So perimeter of the square. Perimeter of the square. Perimeter of the square. Perimeter of the square. Okay, there's something called the perimeter of the square. In other words, the perimeter of the square is going to be obtained as follows. Remember that this wire that we are dealing with, it's a wire of a given length, namely 12 meters. 12 meters of length would therefore mean that we have 12 meters, and out of the 12 meters of the length of this wire, you're going to subtract 2x, but 3 factors of 2x. So in other words, we're going to subtract 6x, and this is going to give us the perimeter. Remember that we have this length of wire, which is 12 meters, and we subtract 2x for each side of the equilateral triangle. Okay, pay particular attention to the things that matter. So now, there's something called the side length. The side length of square. Right, the side length of the square. Okay, yeah, the perimeter of the square is just the total length of 12 meters, but we subtract the length of each side of these, which is 2x. Okay, now what is the side? Okay, if this here is the perimeter of the square, so in other words, the remaining length after this triangle has been formed, we shall have the total length 12x minus 6x for the length of each side. The side length of the square, you therefore divide this one minus 6x. You divide by 4 because the square has 4 sides. And now this means that it is tantamount to simplification, and you have 6x out of 4. And then what is 12 divided by 4? It is 3 minus 3 over 2x. And this is actually the side length. The side length of square. The side length of square is actually 3 minus 3, yeah, minus 3x out of 2. No, yeah, just note that one because it's very, very important for us to to note. And this here, what section is this, guys? What section is this? I actually was speaking about this on the WhatsApp group, and this is called the optimization. It's called optimization. And what is optimization? Right, optimization. And this optimization pertains something we call, or some people call it mensuration. Mensuration as well. So mensuration is pertaining the applications of calculus to measurements, but also this one is optimization when we want to find optimal quantities like maximum, minimum, and want to find maximized profits. Because sometimes we are in business and we're asking the question, how can we get the most returns? on our investments, and we use calculus to have projections and do a lot of things. So we continue. Right, so yeah, the next question is, if this square is now used as the base of a rectangular prism, so let's build a rectangular prism. Here is a rectangular prism, and you have that. Right, so if this is a rectangular prism, just trying to draw. No, that is not the perfect of architects, but then you do this. So then you do this, and you do that, and you do that. So if this square is now used as the base of a rectangular prism with a height of 4x meters, a height of 4x meters, and now the base of the square is 3 minus 3x out of 2, and you have exactly the same thing because, yeah, it is the base of the square. The base of this rectangular prism is a rectangular prism, so you must know your geometrical shapes. A rectangular prism is just a prism that is formed by rectangles, okay? But we understand something, that the square itself is of some requisite the base is formed by the square we actually obtained, described above. Okay, good. So now let us determine the maximum volume. So let's find the volume of that. So the volume of that is nothing other than, what is the volume of anything in mathematics? So it is always area of base by height. What is area of base by height? It's length by breadth by height. So it is 3 minus 3x over 2. Okay. 3 minus 3x over 2, and then the height, remember that the height is 4x meters, so you put 4x there. Right, so this one you can write 2 times 3 is 6 minus 3x out of 2, and all squared here, and this is 4x. Pay particular attention, guys, because at this point, we're able to make certain observations that these are the same, so you can put a perfect square there. Okay, now at this pointer, you can write this one as 6 minus 3x. You square that, which is 2 squared, and this is 4x. And this, you square the 6, and you square 6, you get 36. 6 times 3 is actually the same as 18 by 2, and 18 by 2 is actually exactly 36 as well. So this is minus 36x plus, you square minus 3, you get a 9x squared. You divide everything by, okay, 2 squared becomes a 4, and this is 4x. Okay, pay particular attention to the story. Now, these 4 cancels out these 4, and we allow further mathematical manipulations, but multiplications through what you call distribution in the numerator. And what we then able to get is that we have 36 by x, which is 36x minus 36x squared, plus you multiply x by 9x squared, you get 9x cubed. This is what we have. Okay, now particular things remain key here, and what are the things that remain key? We are interested in finding something. So this is v of x, which is 9x cubed minus 36x squared plus 36x. Okay, so in the end, then we want to find the derivative of this, which is v prime of x, which is exactly, okay, let's find the derivative. The derivative, so here we got the green part here, which is the volume function. So we have 9 by 3. 9 by 3 is 27. Okay, let's write clearly here. So it's going to be exactly 27x. So this is exactly be 27x squared minus. So 36 by 2 is minus 72x plus 36. In the, what we then have is the fact that this is the derivative, but what do we want with this derivative? We want to find the maximum volume. So we're going to take this derivative and equate it to 0, meaning we have 27x squared minus 72x plus 36 is equal to 0 for max volume. Divide through, you can divide through by a number. Let's divide through by 9. And if you divide 27 by 9, you get exactly 3x squared. Divide 72 by 9. Divide 36 by 9, you get a 4 equals 0. If you divide 72 by 9, because this is like 4 by what? 4 by 18. Dividing, dividing 4 by 18 by 9 will give us 4 by 2, which is exactly 8x, which is exactly 8x. So this is what we have. So then we have 3x squared minus 8x plus 4 equals 0. So you have 3x minus 2. And then x minus 2 is the algebraic factors. At this point, we're able to observe that x is 2/3 or x equals 2. When does the maximum occur? It occurs at 2/3. So 2/3 is equal to it's equal to what we're getting. So it's 9x cubed. So it is 9, which is 2/3 cubed minus 36. 2/3 squared plus 36. 2/3. Okay, this one here is the cube. This one here is the cube. Okay, now let's note the cube. So put the cube there. Using a calculator. Okay, can you do without it as well? But this is going to be exactly 32 divided by 3 cubic meters, which is 10,67 cubic meters. 10,67 cubic meters. And this is actually, we need to determine the maximum volume of the rectangular prism. Determine the maximum volume of the rectangular prism. And the maximum volume is 10,67 cubic meters. Okay, so that's something you need to take note of. And we continue to do more mathematics. We continue as follows. Okay, now I must indicate that this is going to be the maximum volume, but now we got two values of x. The maximum values occurs at this one, because if you check this one, v of 2, if you substitute into the volume function, like we did, okay, volume function, which is this one here, so you're going to have the, yeah, because if the volume function is v of x, which sits as 9x cubed minus 36x squared plus 36x. 9 times 2 cubed minus 36, 2 squared plus 36 times 2. Okay, you get the result. The result is going to be 0. This is 0 cubic meters, and therefore this is not, the question said maximum volume. So at 2, you're going to have what you call minimum volume. At 2, we're going to have minimum volume, and therefore the maximum volume occurs at the other part. Right, so which is the minimum volume? Minimum volume occurs at 2, but the maximum volume occurs at 2/3, and we are done. Next question. Right, in the next question, we have more first principles calculations. Now, 7.1 is saying determine f prime of x from first principles given minus 4x squared as a function. Right, we have f prime of x, which is the limit. the limit as h tends to 0 of f of x plus h minus f of x all divided by h. This gives us f primed of x, the derivative, which is the limit as h tends to 0 of f at x plus h, which is minus 4 of f minus 4 open bracket x plus h. So you have here x plus h, and you square this minus, and you have minus 4x squared, and the result is h. Okay, please, yeah, I must apologize for losing numbers, so I don't know why. I think it's just the network thing, but please, I'll make every effort to make this recording available. So, yeah, so you can be able to get the most out of this. We square the 2, getting x squared, x by h, xh by 2, it is 2xh plus h squared, and we have negative by negative, which is exactly a plus 4x squared, and we divide everything by h. Okay, this gives us the first principles of that expression, meaning we have the f prime of x, which is the limit as h approaches 0, and we distribute, which is minus 4x squared minus 8xh minus 4h squared plus 4x squared, all divided by h. And we cancel these 2 here, which means therefore we have f prime of x equals the limit as h tends to 0, and we have minus 8xh minus 4h squared over h, meaning that you have the limit as h tends to 0. Okay, your h open bracket minus xh minus 4h over that. Okay, so this approaches 0, which means if primed, which is minus, okay, the limit, which is exactly the limit as h tends to 0. The limit as h tends to 0 of minus 8x minus 4h. As h tends to 0, therefore this is exactly minus 8x minus 4 times 0. And therefore, f primed of x is minus 8x. And this is the answer to the question. Okay, what kind of answer is this? It is telling us that the actual derivative at any point, the derivative at any point is actually minus 8x. Okay, obviously we're given something, and we're given minus 4x squared, and we have this is the result. Okay, this just one more question on the first principles of differentiation. So something that you must take note of. During your own leisure, watch these videos and make sure that you practice and make sure that you can understand the first principles, because I'm going to come back tomorrow and do other sections because today we devoted this one to more calculus, and we're going to see more questions moving forward. We move on to the next question. In the next question, we want to find the first derivative, which is f prime of x. Meaning with f of x, which is 2x cubed minus 3x. F primed, okay, we want to find the derivative of this, but now once again, we remind each other that at this point, we used the first principles in the next question, in the previous question rather, but in this question, we shall use it called the power rule. The power rule of differential calculus, of differentiation, and it says y equals, okay, I stated this in terms of f of x, so let's do the same. It is common practice that the examiners always use the same notation. F of x equals x to the power n implies that f prime of x is the same as nx to the power n minus 1. Now, the power rule, what does it say, actually? Well, it says that you bring down the power and subtract 1 from the power n. Okay, if this is 2 times 3, you bring down the 3 and you subtract, oh, yeah, you subtracted 3, you subtract 1 from the 3, that appears as the power of x. Okay, you have this one times x to the power 1 minus 1, which means, okay, you have this one here. 2 times 3, 6 squared minus 3x to the power 0. And you have this, which is 6x squared minus 3. Now we continue. Okay. We continue. Okay, so yeah, and this one here is the answer to the question. It is most definitely the answer to the question. So yeah, pay particular attention to this in question 7. Pay particular attention to these in question 7. Next question. In the next question, we're looking at 7.2.2. In 7.2.2, we're looking at the dx notation. Capital Dx. Open round bracket, the cube root of x squared plus 2x to the minus 5. This equals the capital Dx notation, 7 times x to the power 2/3 plus 2x to the minus 5, which is 2 over 3 x to the power z minus 1 plus 2 minus 5x to the minus 6. So this is 7 by 2, which is exactly 14 out of 3, because 7 by 2 is 14 out of 3, x to the power 2/3 minus 1. What is 2/3 minus 1? It's actually minus 1/3. Check this. Okay, so yeah, that minus 1/3 is the power. Yeah, that's minus 1/3 is the power, and we also have here 2 times minus 5, because it gives us a minus 10x to the minus 6. So that, yeah, that is the answer, but please always is advisable to write your answer with positive exponents so that you have out of 3x to 1/3 minus 10 over x to the power 6. Minus 10x to the power 6. Minus 10x to the power 6. So we continue right now to solve these particular questions. We continue right now to solve these particular questions here. We'll look at the next one. We'll look at the next question. And the next question is question 7.3, and let's do that. In question 7.3, the examiner is very clear about the fact that for each of f of x, will the tangent to f of x equals minus 2x cubed plus 8x have a positive gradient? For each of x, will the tangent to f of x equals minus 2x cubed plus 8x have a positive gradient? And we analyze that. Okay, so if we're saying for each of x with a tangent to this, a tangent to that means that we need to find the slope, the gradient at any point, meaning f of x itself is minus 2x cubed plus 8x. Then we need the derivative. You have minus 2 times 3, which is minus 6x to the power 3 minus 1, which is 2 plus 8 to the power 1, which is times 1 times x to the power 1 minus 1. If primed is minus 2x squared plus 8x to the 0th power. Okay. So there we can write here the first derivative is actually minus 6x squared plus 8. Okay, now this is the derivative, but for each of x, will the tangent to this have a positive gradient? So we are actually making the derivative plus 8x have a positive gradient because it is f prime of x this, but we want the gradient to be positive. The gradient to be positive. So if it is a positive gradient, then what do we then have? We need to just solve for x here so we can transpose everything. So at this point, we can have minus 6x squared is bigger than minus 8. You divide by minus 6 so that x squared is less than 8 over 6. So remember to change the direction of the inequality because we are dealing with, we are dividing by negative. So the inequality must change from greater than to less than. Now we have the critical values. We have what you call the critical values. Okay, let's look at the critical values. Right, so dealing with critical values, we have the following. Right, so dealing with critical values, we'd have therefore that if you take the square roots both sides here, and the square root, it's gonna be what? As a matter of fact, here. Right, so you're gonna have therefore that x is what? Okay, so this first would mean that x squared is less than. You divide this one by 2, getting a 4 out of 3, taking the square root, would therefore mean that x is minus 2 over the square root of 3, or x equals 2 over the square root of 3. Okay, so positive 4, positive 4. Obviously, because we require that this is positive gradient, so positive 4, we use the graphs we learned from grade 11 and grade 10, the quadratics. So this is minus 2 over the square root of 3, but also it is 2 out of the square root of 3. Okay, pay particular attention to the patterns we use. Okay, now, what do we have here? Okay, we want these to be greater than 0. At greater than 0 part, so we want these to be exactly above here, and we would be interested in this. Okay, good. But now because we've already divided by negative, we're interested in the parts, would be interested in the parts where this is less than 0. So yeah, so we're looking at this part here. Looking at this part wherever it's less than 0, and that's the part we need. Right, so in the end then, what we then have is that the part less than 0, and what is the part less than 0? The part less than 0 would be actually intermediate values between minus 2 out of the square root of 3 less than x less than 2 square root of 3, like so. Okay, so here we're therefore saying positive for x lying between those two extremes. Yeah. Yes, positive for those because now positive here, but now at this point we divide by negative and getting the inequality to actually be less than at this point. But this graph is the graph with the minimum vertex when the coefficient is positive. So after we divide it by negative, so that we agree therefore that when x lies between minus 2 square root of 3 and 2 square root of 3, we have the graph exactly that way. And therefore we're interested in parts where this is it's going to be at this point of the division by negative, it's going to be negative and it's negative below. Okay, too many ways to kill a cat. Let's get the next question. Let's look at what the examiners want to see you guys doing to excel in mathematics and become the best versions of yourselves. Next point. Next point. The next one is about the turning points of functions. And let's just look at this question and make sure that we understand this entire question, but also we solve this with much ease. Let's get to the question. Right, given f of x equals minus x cubed plus 6x squared minus 9x plus 4 equals this. This is the factorized version of the function. 8.1, the examiner is saying determine the coordinates of the turning points of f. What are the coordinates of the turning points of f? Right, so to find the coordinates of the turning points of f, we find the derivative. We evaluate the derivative. So first things first, we're going to take f of x, which is minus x cubed plus 6x squared minus 9x plus 4. We find the prime. Minus 3x squared plus 12x minus 9. Okay, you want to find the turning points, and to find the turning points, what we do is we equate these to 0. Dividing through by -3, you have x squared minus 4x plus 9 plus 3 equals 0. Okay, pay particular attention to this. Meaning, we can find the factors. So which is x minus 3, x minus 1 equals 0. And therefore, this means that x equals 3 or x equals 1. Okay, now let's look at these and what the implications are of this, and want to find the coordinates of the turning points. Now we're going to perform substitutions like at x equals 3, we're going to have that if or evaluated 3 of the function, original function, which is minus, you put the 3, you cube it, plus 6, you have the 3 square, minus 9 by 3, you add 4, and you have the result. And what is the result? The result is a 4. And then here you have x equals 1, which means therefore you have f of 1 is equal to minus 1 cubed plus 6 times 1 squared minus 9 times 1 plus 4. The result is exactly a big note, meaning f of 1 is 0. Now, what are the turning points? Right, so there are certain points which are called turning points of the original function, and the turning points are as follows. Meaning that when x is 3, y is 4. And when x is 1, y is 0. And determine the coordinates of the turning points of f, and therefore we found the coordinates of the turning points of f. Okay, we continue. So the next thing is now to draw a sketch graph of f, clearly label label all intercepts to the axis and any turning points. Let us look at this question, but look at this question very, very carefully, and we proceed as follows. Now, at this point, to draw a sketch graph of this, we proceed as follows. Let's just sketch very, very easily. Right, so we know this is a y-axis and this remains our x-axis. The x-intercept will occur, okay, with something we did not quite do, but yeah, we can state the x-intercept. The x-intercept occur, we let y be 0. When that is the case, you have x minus 1 squared, and then we have this one here equals 0, which means x equals 1, x equals 1, x equals 4, which means x equals 1, x equals 4. And this kind of a graph is a very, very important sort of graph. Okay, because I've taken the factorized version of the graph, just to pay particular attention to that part. Okay, so the couple of things that remain key to us. This graph, because it has a negative here, will always have a maximum, and then you extend it to the other side like this. So this is sort of the shape of the function. So at this point, you have the turning points, and we know what the turning points are. What are they? So this is gonna go up like this. Okay, yar. Ooh. Okay, yeah, just gonna finish it off. Now we're gonna draw here a horizontal. Gonna draw a horizontal line, the x-axis, and then we're gonna draw okay, and then we're gonna finish the graph off like this. So you have this, F, which is exactly 3 and 4. Okay, there's another turning point with the coordinates 1 and 0. Remember, we got the turning point coordinates 1 and 0, and the other one with 3 and 4 coordinates. And we've put the 3 and 4 coordinates, and this is the graph F. So we drew, and we have drawn a sketch graph of F. Clearly, we labeled all the intercepts with axes and any turning points. Yeah, we're good. And this is it. This is exactly what we had to do in this question. Next point. Use the graph to determine the values of k for which this is the case. Let's look at the graph. And now we're looking at 8.3. And yeah. So now we're going to have this graph here. And this graph is like this. We just drew it before. Here it is 1 and 0. There it is 3 and 4. And here it is 4. This is our y-axis and this is our x-axis. And I want us to analyze this and to look at use the graph to determine the values of k for which this is equal to k. This equals k. So we're dealing with the y equals k graph. But you see, there are two graphs here that intersect. But now this one has three distinct points. Three distinct points. Okay, remember that we need to use the graph to determine the values of k, for which this one will have three real and unequal roots. Three real and unequal roots. Okay, so they're unequal, but if the graph is to touch here, it's going to have three roots, two of which will be equal. So if it cuts here as well, it's going to have, because yeah, this is a cubic function, so there's going to be three roots, but two will be repeated here, and it's going to be a different root there. So to make sure, therefore, that we have that you need to use the graph to determine the values of k, for which these will have three real and unequal roots. That means, therefore, we have that our k is between 0 and 4. So yeah, because it's between 0 and 4. So yeah, you have because this k is equal to the y function. So it's like y equals y. And y is clearly 0 at the origin, but y is 4 there. So which means that k is between 0 and 4. If you don't want to say that, you can say that k is an element of the interval from 0 to 4. Okay, we're done with that part. We proceed to the next question. Right, in 8.4, we want to deal with the line. The line, for instance, g of x equals ax plus b is a tangent. Okay, let's look at that one. Let's provide now space for it. Okay, this line here is the tangent. The line g of x equals ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. Determine the equation of g. Now, there's something we call the point of inflection of a function in 8.4. Given the original function, which is f of x equals, right, so we know very well the function that was given there. And we need to just quote it and make sure that we're good, right? Let's just make sure we have the, so it's minus x cubed plus 6x squared minus 9x, so minus x cubed plus 6x squared. Minus x cubed plus, okay, it's here. Minus x squared plus, minus x cubed plus 6x squared minus 9x plus 4. Okay. Now, look. The line g of x equals ax plus b is a tangent to f at the point of inflection of f. Determine the equation of g. Right, but if this line is a tangent at the point of inflection, so we must find the point of inflection. So to find the point of inflection, we're interested in what we call the inflection point. Right, we're interested in the inflection point. If we're interested in the inflection point, we find the second derivative. Okay, but first we must find the first derivative, step by step. Yes. So the first derivative is what? Okay, by the power rule, we bring down 3. From 3 subtract, you get a 2. 2 by 6 gives us 12x. Minus 9, the derivative is a 1. We find the second derivative. Okay, the derivative of the 4 is 0. The derivative of a number, a constant, is 0. Second derivative of the function is minus 6x plus 12, and this is naught. Okay, we get it to 0 so that we have minus 6x equals minus 12. You divide by minus 6 so that we have minus 12 over minus 6 is equal to 2. Okay. So this kind of a graph, obviously, is a graph that is very, very important to us, okay? And we analyze it in detail then. So, and it means, therefore, would have that at x equals 2, you need to substitute into a original function and get the corresponding value. So you have f of 2 substituting into exactly that part. So you have minus 2 cubed plus 6 times 2, you square that, minus 9 times 2 plus 4. It means, therefore, you have this one. The result is going to be 2. Let's just check this out. Okay, to avoid just human error. So this is exactly minus 8 plus your 6 by 4, which is 24, minus 18 plus 4. And this is actually 16 minus 16. And 16 minus 16 is a big let's see what we have here. This one is 4, 16, and this one is minus 14. Okay, so this one is a minus 14. So it's 16 minus 14, and 16 minus 14 is actually a 2. So yeah. So then what we then have is the fact that you have a point, the 2 points. The 2 points. Okay, right. And obviously, it's something very, very important to take note of there. Okay, right. So we continue to analyze the question then, and then be interested in finding the answering the question obviously precisely because we found the inflection point. But what kind of an inflection point is this? So it will be very, very interesting to take note of what really happens if there's a sign change on either side of this point, and if this is indeed a point of inflection. So, okay, we need to investigate just very briefly the inflection point. So, you need to obviously now analyze if this particular second derivative appears to sort of change sign. What happens when x is bigger than 2, for example? Right, so when x is bigger than 2, you're gonna have exactly a minus. When x is smaller than 2, you're gonna have a plus. And indeed, there is a sign change. Indeed, there is certainly a sign change. So in other words, what you have is if this is the f second derivative, it means, therefore, that here there are 2 cases of the function. Right, so the function is going to be concave down here, and the function is going to be concave up at this point. So if that is the case, the function is concave up and then is concave down. It means, therefore, you have a maximum to 2 point. Okay, maximum to 2 point. Now, we want to therefore find, okay, this one is a tangent to f. At a point of inflection of f, determine the equation of g. So if you have a tangent to f has a slope. We need to find f primed at 2. Okay, what is f primed at 2? This is f primed So at 2, then it's going to be exactly minus 3, 2 squared plus 12 times 2 minus a big 9, f primed at 2 equals, let's check this one, because a big 3, so that you have y minus y1, which is m into x minus x1. Okay, so it passes through. It passes through. Okay, so it passes through 2, 2. It passes through 2, 2, but this is the gradient. So if you have this one is x1, y1, so it's y minus 2. The slope is 3 into x minus 2. Y equals 3x minus 6 plus 2, which is minus 4. Minus 3x minus 4. So obviously, and we need to, the line, this is a tangent to f at the point of inflection, determine the equation of g. So in other words, the equation of g is actually 3x minus 4. So pay particular attention to these. These are like past exam questions on general mathematics. General mathematics. Advanced, this is called differential calculus. This kind of topic we're doing is called differential calculus. So it's not child's play, but it's very, very important. Let us look at the angle of inclination next. Now, calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant of the plane. Okay, now there's something about the angle of inclination, in particular the acute angle between G and the x-axis. We recall that the function g of x we just found, its equation is actually as given here. So g of x is here is 3x minus 4. 3x minus 4. Okay, so your when x is 0, y is minus 4. When y is 0, you'd have therefore that x is positive, and you'd have a graph like this. In particular, when y is 0, x itself becomes 4 out of 3, giving us this angle theta. So now at this point, you have the tangent of theta. The tangent of theta is going to be this guy here, which is the gradient 3. Theta is arctan, which is 71,57 degrees. If you use the calculator, which is the arctan. So we define the angle theta, and the angle theta is actually 71,57 degrees. Just pay particular attention to that. Next point. Question 9 is about this diagram here, but it's a very, very fascinating diagram, and the examiners sometimes go way, way above and beyond to ensure they're creative, but they go out of their way to get you to learn mathematics, but also to demonstrate your ability in the exam. The diagram below represents a printed poster, rectangle ABCD. Now, this ABCD, the rectangle, is part on which the text is printed. So the text is printed and that has been grayed out. This shaded area ABCD is 432 square centimeters, and AD is x centimeters. So you have that obviously your AD is x centimeters. Now let's just measure it here and have this. So it's actually x centimeters. And ABCD is 4 centimeters. Let's see that. So if you have that, it's 4 centimeters from the left. So you have 4 centimeters from the left. And in the right edges of the page, and 3 centimeters from the top and the bottom of the page, you can see 3 there. Show that the total area of the page is given by these. Let's look at the total area of the page. Now, there's the printed area in the gray and the blank part. What is the area? Area is length by breadth. Okay, so what is the length of this? There are a couple of things obvious that you need to take into account, but you need to take into account that we have first the area of the interior. Right, so the area of the interior here is nothing other than what? The area of the part that is grayed out. So we can give this one the name breadth, and we can give this one the x name, so that now we have the length is x and the breadth is b. And the shaded area is 432 square centimeters, so it's 432, and this means, therefore, we can be able to get our B, and our B is 432 divided by X, and this is our B. Now, the area is actually length by breadth of the whole thing, So, which means, therefore, now the area is the length of the whole thing. So here, the whole thing. Now pay attention to the fact that this one is x for from here to there, but there is 4. So it is x plus 8. X plus 8. And then in the end, then we have 3, which is 6, which is like b plus 6. Okay, because this one is like B for breadth, the breadth of the printed part that is text on it. But you also have 3 here, which is actually B plus 6. Now, the length, therefore, becomes X plus 8, and the breadth becomes exactly B plus 6. Pay particular attention to these. As we proceed to analyze this question, we are able to find more interesting facts. So the area becomes x plus 8, but we're able to see the breadth. What is the breadth? The breadth is actually 432 out of x plus 6 exactly. So, which means that the area, we can call it A as a function of x. We open by distribution, multiplying x by 432, which is 432, plus x by 6, which is 6x, plus 8 by 432, then it is 3, 4, 5, 6 divided by x, then 8 by 6 is actually exactly 48. What is a of x? So that a of x is the same as what? So it's exactly the same as 3, 4, 5, 6 out of x. And now we have plus 6x. Okay, and then we have also 432 plus 48, 432 plus 48, which is actually 480. 480. So this one here would give us the total area of the page, and this a of x equals this. And exactly what the examiner wanted us to show there for a beautiful 3 marks, and we've shown that. I believe that this is very clear, but if there are questions, please, you can always let me know. In question 9.2, the examiner is saying determine the value of x such that the total area of the page is a minimum. And we are able to minimize the area as follows. So in 9.2, now we know, therefore, first things first, that the area itself was determined in the previous question. So this one is a hands question, and the answer entirely depends on the answer to question 9.2 entirely depends on the previous question. So the area, which is 3, 4, 5, 6 divided by x, which is exactly 6x plus 480. Okay, so we are able to find the slope. And what is the slope? The slope, okay, before we find the derivative of this, we can write this as 3, 4, 5, 6 x to the power minus 1 plus 6x plus 480. And this is a primed of x, which is actually minus 3, 4, 5, 6x to the minus 2 plus 6. Okay, because the derivative of 6x is actually just 6. The derivative of x is always 1. But here with the minus 1, you bring down the minus 1 and then you subtract 1 from it. The derivative of the 480 becomes a big 0. And then in the end, what are we able to then get? We're then able to get the following. So it is actually, remember that we want to get the actual value of x here. So we can move this on the other side so that we have 3, 4, 5, 6, x to the minus 2 is 6. Okay. And then we continue to analyze these things here, which is 3, 4, 5, 6 over x squared equals 6. You cross multiply this, which is 3, 4, 5, 6, which is 6x squared. Okay, we divide through by Okay, we want to solve for x squared here. You need to divide through by 6, getting exactly x squared, which is 3456. You divide by 6. And if you divide, you get 576. Check this. And x therefore becomes, if you have x squared equals this, the square root, which is x equals 24 centimeters. 24 centimeters. So we determine the value of x such that the total surface area, the total area of the page is the minimum, and x is actually exactly 24 centimeters there. Okay, so we have solved this particular problem. Right, guys, I must thank you for joining us. It was awesome having a discussion with you. This was differential calculus. So we've spent a considerable amount of time this evening doing what we call differential calculus. Okay, so there are many types of calculus. Like I said already, there's something we call integral calculus. Integral calculus is done by those students who are doing what we call technical mathematics. And yeah, if you're doing technical math, you let me know. If there's somebody who needs help with technical mathematics, we offer technical mathematics at the highest level, at the level of university mathematics. Yeah, so I must thank you guys for joining us. It was awesome having a discussion with you. Until tomorrow. Have yourself a good evening. But I'm going to post a lot of questions, practice questions on the WhatsApp group for you to practice. But from us, it was awesome having a discussion with you. And yeah, this has been differential calculus in action.